Hello, my amazing Algebra Half students. This is Mrs. A, and I love math. And today we're working on lesson 90 in our Saxon Blue book, and we are talking about surface area of a right solid. Now, a right solid, this paper towel roll, is a right solid. Okay, it's right because when I set it on the table, in this case my hand, then the sides go straight up. In other words, this base, which is on the table or my hand, and the side make a right angle, right? It's 90 degrees in there from here to here. So that is what a right solid is. When you sit it on the table, it goes straight up. It doesn't slant at all. That's our right solid. Now, when we use when we're talking about the lateral surface area of a right solid, we're talking about the area around the right solid, not including the bottom area, we're pretending that's solid, and not including the top area. Okay, so the lateral means around the sides. So when we're looking at this nice roll of toilet paper, it's very easy to find the lateral surface area because it's a roll of paper towels. So what we're going to do is I'm going to take my little line and I'm going to make a little marker all the way down. Okay, so my marker's a little bit dull there, but I can see the line. Okay, and hopefully you can see the line. It's just kind of, my marker was duller than I thought. But that square, oh, it's just a little bit longer than my actual seam, isn't it? All right, I need to use up more of my paper towels, and then I could have just ripped it there, but that would be wasteful, wouldn't it? Okay, so can you see the line? I'll draw it a little bit better now that I have a better marker. So we'll just go all the way down. All right, so the area of that rectangle would be my lateral surface area. So notice what I did. I had my paper towel all rolled up, okay, and then right where the paper was rolling, I made a line with my marker. And then when I unroll the paper towel, isn't that rectangle the same as just unfolding the outside of the paper towel? And so if I measured that rectangle, and rectangles have length and width, then I would have the lateral surface area. So let's do that again. This distance around from this line all the way around the paper towel roll is the distance around a circle from that line point right there all the way around the circle. What do we call that distance around a circle? Do you remember? It's called the circumference. So the circumference of the circle would give me the what? Distance across my top of my paper towel roll, right? And then wouldn't this distance over here just be the height of my paper towel roll? So the lateral surface area of a cylinder, this is a cylinder, a right cylinder. The lateral surface area is the circumference of the circle times the height of the paper towel roll or the cylinder. Okay, so that is a formula that we'll use. Now our first example, and how do we calculate the circumference? Do you remember the formula for circumference is 2 pi r. So our picture looks like this. Okay, you see the right circular cylinder, and this right here across the top is the radius of the cylinder. And then over here, we're talking about the area of that unrolled paper towel there. And it's the circumference is the distance around the top, which was the distance around the circle before you unfolded it, 2 pi r. and then this is the height of the paper towels. So the lateral surface area equals the height of the cylinder times the circumference of the top of the cylinder. Okay, so we can use the same procedure to find the lateral surface area of any right solid. So what was this? It was the distance around the base times the height. And that's what we're going to use for lateral surface area. I wanted to show you in the book the figure because I am not an artist. And their picture of the figure is much better than mine. And it says find the surface area of the right triangular solid shown. And the dimensions are in meters. So we're going to do this one. This is example 1. Now here's my pretty pitiful picture that is supposed to look like the other one you just saw. But notice that this is a triangular prism. It's got a triangle on one side and there's a little triangle on the other side. But then the other 3 sides are rectangles. So what I'm going to do is I'm going to use my nameplate to represent this triangular prism. Now my nameplate is not exactly a triangle. You see it got a little bit cut off, but we're going to pretend that it's a triangle. We're going to pretend that this is a triangle and this is a triangle, and then there's 1, 2, 3 other sides. We're just going to ignore this one down here, all right? Because we're trying to do a triangular prism, and that's the closest thing I have to a triangular prism. All right, so we have a top triangle, and we have a bottom triangle, and they're the same. So we only need to find the area of the triangle once, and then we can double it. So that would be the base and the top. And then I have 3 sides, and they're not the same, okay? But since it's a triangle on the bottom, pretending, it has only 3 sides that we have to take care of, okay? So we have 5 sides altogether that we're going to take care of. And remember, the lateral surface area, just like we looked at our cylinder. Remember, on our cylinder here, the lateral surface area was the distance around the base times the height. And the distance around a circular base was a circumference. But the distance around a triangular base is not going to be a circumference. We're going to call it a perimeter. Okay, so our lateral surface area will be perimeter of the base times the height of the figure. That will be the lateral surface area. Okay, now we're going to find total surface area here, but that would be the lateral surface area. So your book is giving you that formula for lateral surface area, and then we will add the area of the 2 triangles to it. So the perimeter of the base is 4 plus 5 plus 3. So 9 plus 3 is 12. So the perimeter of the base is 12. And then we're going to say times the height of the figure. Okay, so how tall is this figure? Well, this length here is 16. And if we set this thing up on its base like this, then wouldn't the height of it be 16? All right, so we're going to say the perimeter of the base times 16 should give us the area of all the 3 sides except for the 2 triangles here. Okay, so 12 times 16. What is 12 times 16? And that's going to be 12 and 7 and 12. 192. 192 plus, we're going to figure this out 2 ways, plus the area of the 2 triangles. Now, the area of a triangle is 1/2 base times height. okay, of the triangle. So area of a triangle is 1/2 base times height. So now we'll just call this the base. Okay, so 1/2 3 times 4. So 1/2 3 times 4, 3 times 4 is 12. 1/2 3 times 4 is 6. So now we have the triangle is 6. The other triangle also has an area of 6. So we're going to have the 192 plus the 6 plus the other 6 is 192 plus 12. So the entire surface area of the whole figure would be 192 plus 12, which would be 204. Okay, now that's one way to find the area of the figure. And the area is 204, and since they said it was in meters, meters squared. So we did it using the lateral surface area formula. But we could also do it a different way. We could say, well, this one right here, although it looks like it's just a parallelogram, is really a rectangle, right? Because this is just a picture of that rectangle. So this rectangle, length times width, is 5 times 16. So 5 times 16 is the area of one side, and 5 times 16 is 80. Okay, so this one has a area of 80. Now let's think about the one that's on the back side of this rectangle. Okay, and it has a side of 4 times 16. If that's 16, then isn't that one 16, right? So 4 times 16 is 64. So 4 times 16 is 64. So now we've taken care of 2 of our sides. We've taken care of this one on the front and the one that's in the back. And we have one more side, which is the one there it's sitting on. The bottom side, right? It's sitting on it, is 3 times 16. So 3 times 16 is the last of the lateral sides. So 3 times 16 is 48. So now when I add together, oops, I lost my 0. When I add together my 80 and my 64 and my 48, what do I get? So 4 plus 8 is 12. And then 14 plus 1 is 15 plus 4 is 192. Do you remember what I got? When I did the lateral surface area formula, I got 192. And now I just got 192, adding the individual areas up together. Okay, so you can do either way and you're going to get the right answer. So 192 was the lateral surface area, and then I have to add on the 2 triangular sides. So we already figured out that the area of the triangle was 6 square meters. So we add the 6 square meters twice. So the 192 plus the 12 square meters again is 204 square meters. And we just confirmed our answer because we did it 2 ways. We did it once with the formula, lateral surface area times, lateral surface area is perimeter of the base times the height. Okay, so we took perimeter of the base times the height, and we got 192 the first time, and then we took them apart and did them as 3 separate rectangles and got 192 again. And then we added the triangles that are on the 2 bases, and we got 204 square meters again. All right, so here we're doing lateral surface area of the funny figure that's in your book. Now this is the base of the figure, but then the figure is 30 feet high. Everything is in feet, but then it's 30 feet high. So they have the figure drawn in your book, but this is the base, the bottom of the figure, and then it rises 30 feet high. So it looks a little odd, but the base is made up of a rectangle and a half of a circle, which you will see a lot of figures done this way. All right, so now We know that a rectangle, its area, we're doing lateral surface area. So we don't need the area of any of this. We need the perimeter. Okay, so the perimeter of the figure does not include this side. You see, I've made this one dashed. So we've got 8 plus 6 plus 8. And then, since this is a circle, don't we need a circumference of a half a circle, which is half of the circumference of the whole circle. So circumference is 2 pi r. So wouldn't half the circumference just be 1/2 of the circumference is just divide by 2. So we're looking for pi r. So 3 times pi. And pi is a number that's close to 3.14. Okay, so 3 pi plus 8 plus 6 plus 8. And that would be 16 plus 6 is 22 plus 3 pi. Okay, now on this one, they want us to go ahead and use 3.14 for the pi. So we're going to use 3.14 as a good approximation for the number pi. So here we're going to take out the pi and we're going to multiply by 3.14. Okay, so now this part of it is going to be 3 times 4 is 12, carry the 1, and a 4, and a 9. So we get 9.42 plus 22. So the distance all the way around this figure is this plus this, which is 31.42. So 31.42 is the perimeter of the whole figure. And now, remember, lateral surface area is what we're looking for. And lateral surface area is the perimeter of the figure times the height of the figure. So the height of the figure was 30 feet. So the perimeter times the height is going to be this times this, which, we can do a little cheat here. The 0 is just multiplying by a 10, right? So that's going to move my decimal 1 to the right. So I can multiply by 3 and then move my decimal 1 to the right. So I'm going to have 3 times 2 is 6. And 4 times 3 is 12. So I'm going to carry my 1. And 3 times 1 is 3 plus 1 is 4. And then 3 times 3 is 9. And then we're going to move our decimal from here, 1 to the right, 942.6. Let's see if we got it right. Yes, we did. But the same thing they got in the book, 942.6. Now we get to do our practice. Here is the picture of our practice. I figured I'd let you see it because I can't draw that well. And then we're supposed to find the lateral surface area of the right solid when it is 40 meters high. All dimensions are in meters. Here's our figure. And lateral surface area is perimeter, so we'll put LSA, is perimeter of the base times the height of the whole figure. Okay, well, the perimeter of the base is just going to be the distance around this thing. So there's nothing really to figure out, just add it all up, because each side of the figure is labeled, and this is just the dotted line to show that this is a triangle and this is a rectangle. Okay, so 4 plus 4 plus 4 is 12. 12 plus 6 is 18. So the perimeter of the base is 18 times the height of the whole figure, and the height of the whole figure was 40 meters. So 40 meters. This is in meters, and this is in meters. So won't our answer be in meters squared? all area is in square units, isn't it? So now we're going to just do 18 times 40, and we're just going to, because of the 40, we'll just tack on a 0, and then 8 times 4 is 32, and then 4 plus 3 is 7, 720 square meters. And we are done with lesson 90. I hope you've enjoyed working with surface area and lateral surface area. And this is Mrs. A. And may God bless your day.